let's dive in. Today, we're going on a pretty incredible journey. We're going to start with a simple vibration in the air, follow it all the way into the human brain, and end up exploring a hidden world of sound. So, let me just start with a question for you. What if you could actually see sound? I know, it sounds a little like science fiction, right? But stick with me, because by the end of this, you'll see how science has, in a very real way, made that possible. To understand how we could ever see sound, we first have to get a handle on what it is. So let's start with the absolute fundamentals, the basic physics of it all. At its very core, sound is just a mechanical wave. Seriously, you can think of it as ripples of pressure moving through stuff. And it needs that stuff, a medium, to travel. That's why in the total vacuum of space, there's just silence. There's no air, no water, nothing for the wave to travel through. Now, here's the cool part. Every single sound you've ever heard can be broken down into two main properties. First, you've got amplitude. That's just the raw power of that pressure wave, which our brains interpret as loudness. A whisper has a tiny little amplitude, while a jet engine has a massive one. Then there's frequency. That's how fast the wave is vibrating, and we perceive that as pitch. A low, booming bass note has a low frequency, and a high, shrill whistle, a really, really high frequency. Okay, so that pressure wave is moving through the air. But how does it go from being just a simple wave to something we experience as, music or a friend's voice? Well, that's where the magic happens, inside this incredible biological machine we call the ear. The whole process is this beautiful three-step chain reaction. First, the shape of your outer ear, the part you can see, it acts like a funnel, grabbing those sound waves and guiding them in. Next, the middle ear takes over. The sound hits your eardrum, and its vibrations get passed along and amplified by three of the absolute tiniest bones in your entire body. Finally, these now much stronger vibrations enter the fluid-filled inner ear, where this amazing little snail-shaped thing called the cochlea turns them into electrical signals the brain can actually understand. But wait, why is that amplification step so important? Why bother? It's all because of something called acoustic impedance. You see, the air in your middle ear is really thin, but the fluid in your inner ear is pretty dense. Trying to get a signal from the air to the fluid is kind of like trying to push someone on a swing versus trying to push them through the water in a pool. It's way harder, right? So those tiny middle ear bones act like a lever, concentrating all that force so the signal doesn't just fizzle out when it hits the dense fluid. It's a brilliant piece of natural engineering. So then, how do we tell different notes apart? The secret is hidden inside the cochlea, on a little structure called the basilar membrane. See, it's not the same all the way along. It's narrow and stiff right at the entrance, and it gets wider and more flexible the deeper you go. High-frequency sounds have just enough energy to vibrate that stiff part right at the beginning. But low-frequency sounds, they travel all the way down to the floppy end. It's basically a tiny piano keyboard unrolled right inside your ear, with each little section perfectly tuned to a specific note. But here's the thing. What about all the sounds our biological piano can't play? I mean, the human ear is incredible, but it's also incredibly limited. Let's take a look at the vast world of sound that we literally cannot hear. Our ears are tuned to a range from about 20 hertz to 20,000 hertz. And that seems pretty wide, but when you look at the entire acoustic spectrum, it's just this tiny, tiny sliver of what's actually out there. Below our range, you have infrasound, these deep, powerful rumbles. And way above it, you have ultrasound, high-frequency vibrations that are completely silent to us. And of course, nature has found some incredible ways to use these hidden frequencies. Animals like elephants and whales use that low-frequency infrasound to communicate across huge distances through the ground and water. And then on the other end of the spectrum, you have bats and dolphins. They use high-frequency ultrasound like a biological sonar system. It's called echolocation. They blast out these ultrasonic clicks and listen for the echoes to navigate and hunt in complete darkness. It's amazing. And that brings us to the final and maybe the most mind-blowing part of our story. If animals can use sound to see in the dark, what can we do with it? Well, let's look at how science has harnessed these invisible frequencies to perform what are basically medical miracles. So, how is it possible? How can a wave of pressure let us see inside ourselves? Well, the principle is surprisingly similar to that bat using echolocation. But instead of navigating a dark cave, we're navigating the human body. The medical uses for ultrasound are just incredible, and they usually fall into one of two camps. First, there's diagnostics. That's what most of us think of.
We send high-frequency sound waves into the body, a computer measures the echoes that bounce back, and it builds a live picture of organs and tissues. But it's also used for therapy. We can use powerful, focused ultrasound to do things like shatter painful kidney stones without making a single cut, or even help push medicine deeper into tissues.
But to unlock ultrasound's most amazing abilities, we need one more piece of the puzzle, and it's something you've actually experienced 1,000 times. It's called the Doppler effect. It's the reason an ambulance siren sounds higher pitched as it's racing towards you, and then drops to a lower pitch as it drives away. That's the Doppler effect in action.
And this is where sound becomes a superpower. Doctors can send ultrasound waves into a blood vessel, and those waves bounce off the red blood cells moving inside. By measuring how much the frequency of that returning echo has shifted, they can calculate the exact speed and direction of your blood flow. This lets them spot dangerous blockages and other problems. They're essentially using sound to see the flow of life itself.
So, from a simple wave of pressure in the air to a tool that lets us see inside our own bodies, the journey of sound is just astonishing. It shapes our world in ways we can hear, obviously, but also in these profound ways we can't. It just makes you wonder, doesn't it? What's the next invisible force all around us that we're going to learn to see with?